This lesson shows how to graph the rational function 4 over x squared minus 4. In previous lessons, you've learned about the four important parts of a rational function. Vertical asymptote is a vertical line where the function is not defined. The graph curves up or down as it approaches its VA. The horizontal asymptote is a horizontal line that the graph approaches away from the VA, curving down from above or up from below. The y-intercept is where the graph crosses the y-axis, and the x-intercept is where the graph crosses the x-axis. This lesson shows how to graph the rational function y equals 4 over x squared minus 4 and variations of the function. The VAs are the zeros of the denominator. The denominator factors as x plus 2 times x minus 2, so the function has two VAs at x equal negative 2 and x equal positive 2. For this function, the numerator is degree 0 and the denominator is degree 2. Since the degree of the numerator is less than the degree of the denominator, the HA for the function is the horizontal line y equals 0, the x-axis. To find the y-intercept, evaluate the function for x equals 0. This gives 4 over negative 4, which is negative 1. So the y-intercept for the function is the point 0, negative 1. The x-intercept is the 0 of the numerator. Since the numerator is a constant, it can never be 0, and there is no x-intercept. Next, calculate at least one point on either side of both VAs. Starting at the left, for x equal negative 3, y equals 4 over 5, and there's a point at negative 3, 4 over 5. For x equal negative 1, y equals 4 over negative 3, and there's a point at negative 1, negative 4 over 3. For x equal 1, y equals 4 over negative 3, and there's a point at 1, negative 4 over 3. For x equal 3, y equals 4 over 5, and there's a point at 3, 4 over 5. Finally, sketch the graph of the function. Since the function has no x-intercept from this point at the left, the graph can't curve down, so the graph must curve upwards towards the VA and down from above towards the HA. Between the two VAs, there's no x-intercept, and since these points are below the x-axis, the graph must sweep down towards both VAs. At the right, from this point, the graph can't curve down because that would create an x-intercept. So the graph must curve up towards the VA and down from above towards the HA. So the graph of the function looks like this. Here are some variations of the function. If you increase the constant in the numerator, the graph stretches vertically. For example, notice how this part of the graph is lower and farther from the center of the graph. If you make the constant smaller, the graph shrinks vertically. For example, notice how this part of the graph is higher and closer to the center of the graph. If you replace the constant 4 with -4, the graph is reflected vertically. Notice the middle branch of the graph has been flipped over and is now opening upwards. If you change the factors in the denominator, you can shift the VAs. For this example, there's now a VA at x equal -3 and x equal +4. This lesson showed how to graph the rational function 4 over x squared minus 4. And this lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.